Hey folks, I hope you're doing good. You're having a nice time on vacation. I'm doing these videos out of compulsion. No way I'm trying to imitate Khan Academy here, but let's see how it goes. Yeah. So we do the chapter 11, calorimetry. Now, before we do chapter 11, I would like to do a quick introduction or recap of what we did in class 9. So let's first talk about heat energy. So assume that you have a beaker of water, 1 gram, and you want to increase the temperature by increase temperature by 1 degree Celsius by heating it using a burner or something. Okay, I'm bad in drawings. So so the energy that you spent in increasing the temperature by 1 degree, the energy that gets spent, when I say spent, the energy given by the heater and energy absorbed by the water, the energy that is absorbed is 1 calorie. So by definition, 1 calorie is amount of heat required to increase temperature by 1 degree Celsius. Now this definition is not entirely accurate, because as you increase the temperature of water from, let's say, 50 to 51 degrees, the amount of heat may be slightly different from you know as you try to increase it from 10 to 11 degrees, and the reason is because because of the thermal expansion, right? What we learned last year. So you know, as you heat the water expands, and due to which the amount of heat that you may have to give may be slightly higher. So for this reason, you have to be a little bit more accurate. So 1 calorie is the amount of heat required to increase temperature by 1 degree Celsius from 14.5 to 15.5 degrees Celsius. That's 1 calorie. Now, a calorie is a CGS unit. As you may remember, the SI unit is joules. Now, what is a joule, right? So let's assume that I have you know 100 grams, 0.1 kilogram, right? Now, if you assume that G is equal to 10 meters per second square, we learned that there is the net force that gets applied, which is 0.1 into 10 is equal to 1 Newton, right? So it's a 100-gram object. Now I want to lift this from down to a point which is 1 meter. So by definition, now let me draw a picture of myself. I'm trying to lift it. So by definition, 1 joule is equal to the amount of energy is the amount of energy that I spend in lifting 1 Newton body by 1 meter. Or if I apply a force of 1 Newton over 1 meter, then that's 1 joule, right? So work done is equal to force into displacement. Okay, so if you can imagine, you know, about 420 grams, right? I'm lifting 420 grams by 1 meter. So that's approximately the amount of energy that I'm going to spend is approximately 4.2 joules. Why? Because 420 grams is 4.2 Newton by 1 meter. The force into displacement, that's 4.2 joules. So the amount of energy that I spend in lifting a 420 gram body by 1 meter is exactly the same energy that I spent in heating 1 gram of water by 1 degree Celsius. So this is just to establish an analogy between calories and joules. So remember, key to remember is 1 calorie is equal to 4.2 joules. Now, so if I have 1 liter water, this is approximately going to be 1 kg. The amount of heat that I have to give is 1 kilocalorie. This is equal to 4.2 kilojoules. So keep this in mind as well. I mean, kilo is 4.2 into 10 power 3. Yeah. All right. So let's assume that I have again a beaker of water, and I'm heating it. This is 1 kg water. So I want to increase the temperature from 10 degrees Celsius to 60 degrees Celsius. So I know that for 1 degree Celsius, if 1 kg, I have to give energy of 4.2 kilojoules. So for 50 degrees Celsius, I have to, for 1 kg water, I have to give 4.2 into 10 power 3 into 50 joules, and that's about 2.1 into 10 power 5 joules. That's the amount of energy that I give. And then if I heat 1 gram of water from 10 to 90 degrees Celsius, the amount of energy that I give is 4.2 into 80, that is a delta T. This is an increase in temperature, right? So the amount of energy that because for 1 degree Celsius, I have to, by definition, for 1 degree raise, I have to give, for 1 gram of water, I have to give 4.2 joules. So for 80 degrees raise, then I have to give 4.2 into 80, and that's equal to 336 joules. Now, if I mix both these water, how does the energy flow happen? I mean, first thing, the temperature. I mean, the temperature is, we know that it's going to be somewhere between, the resultant temperature is going to be somewhere between 60 and 80, right? As I mix both of this. Now, it's obvious that that if this body has to, reduce the temperature, heat is flowing from here to here, right? As I mix it, so heat is flowing from body of higher temperature to a body of lower temperature. Now this is not so intuitive, right? Heat, the direction of flow of heat is not so intuitive. Now why it is not intuitive? How can we make it intuitive? Now if you look at this 2.1 into 10 power 5 joules, if you imagine this is the net energy of this water, now what is the energy per gram of water? That's equal to 2.1 into 10 power 5 divided by 10 power 3. That's equal to 210 joules per gram. And in this particular case, this is about 336 divided by 10 by 1 gram. So it's 336 joules per gram. So the average, if I could say the average energy of 1 gram of water, the average internal energy of 1 gram of water is higher than the average internal energy of 1 kilogram of water. And that's the reason why the heat is flowing from a lower net energy, which is 336. There's overall energy to a body with overall higher energy, which is 2.1 and 10 power 5, because average internal energy is lesser in this case, and in this case average internal energy is higher. Now, so let's summarize what we learned. Heat flows from higher temperature, and I'm going to define high temperature as average internal energy to lower temperature till they reach an equilibrium. Temperature, right? So apart from this, what are the key differences between the heat and temperature? This is something we studied last year. So heat by definition is the overall kinetic energy due to random motion of molecules, right? Temperature is basically average internal energy and of a body, and this determines temperature determines direction of flow of heat. The SI unit is joules. The SI unit here is Kelvin. Now it's important to remember that the Kelvin scale ranges from 273 to 373 Kelvin, and that corresponds to 0 degrees Celsius to 100 degrees Celsius. So in essence, 1 Kelvin rise is same as 1 degree Celsius rise. This is very important to remember, very important. And other than this, the other key differences are that calorimetry is used to understand the overall heat energy of a body, and heat energy is additive. When I say additive, if I mix 2 beakers of water, the overall energy of the overall water is additive, right? If energy of beaker 1 is E1 and other is E2, if energy of beaker 1 is E1, the other one is E2, the net energy is equal to E1 plus E2. Now same cannot be told about temperature. So temperature is measured by thermometry, and it's not additive. If I mix 2 beakers of water, one at 60 and other at 90, then the net temperature will not be 150, it will be somewhere in between them, so it's not additive. So those are key difference. I think that's pretty much it for our revision module. So next we will study about calorimetry and 10 syllabus.